Welcome back to the Walnut. In this session, I am going to discuss an interesting way of comparison of fractions. It's a most frequently testing type of question in almost all the aptitude kind of exams. So, how to compare two or more fractions easily? So, most of the situations you will get the questions like this. Arrange the given fractions in ascending order. Before going to arrange the fractions in ascending order, you just consider a basic idea for the comparison of two fractions. So first we are considering the basic comparison of two fractions. Consider two fractions such as a by b and c by d. How to compare these two fractions? So there is an easy way of comparison. So if you need to find out which is greater and which is the least one, we can apply this method. So what you want to do, you just make a cross multiplication like this. This is AB, AB. And consider the product of these two values, that is BC. So if this AD is greater than BC, what is the conclusion here? If AD greater than BC, we can conclude A by B greater than C by D. In the similar way, if this AD is less than BC, what is the conclusion here? This is A by B less than C by D. This is a simple way of comparison of fractions. So I will give one very simple example. Consider fractions 3 by 4 and 7 by 8. Which is greater? While we are multiplying these two values, here 3 into 8, that is 24. If you are multiplying these two values, this is 28. Which is greater? Here 28 is greater. So what we can conclude? This 3 by 4 is less than 7 by 8. This is a simple way of comparison. But while we are considering the arrangements like this, arrange in ascending or descending order, it's a little bit challenging kind of task. Means, if you need to find out which is the largest or the least, within a single step of operation, you can reach the conclusion. But here, it's not like the situation. So what do you want to do? I just give you the basic tips to compare or arrange the fractions in ascending or descending order. So here, consider the first example. What is the peculiarity of this first example? Here we have to arrange the fractions 3 by 17, 11 by 17, 5 by 17. So how we can conclude? What is the interesting peculiarity here? In each case, the denominator is 17. Means we can conclude denominators are equal. Keep that point in your mind. In a set of fractions, if the denominators are equal, then the least fraction contains the least numerator. Keep it in your mind. The least fraction contains the least numerator. Got it? If the denominators are equal. Out of these all fractions, which has the least numerator, this is 3 by 70. So we can arrange the values like this. This is 3 by 17 is the least one. Then, which has a second chance, after this 3, 5 is there. So you can write 5 as the second such fraction, and the largest among them, which has the largest numerator. Here the largest numerator is 11. Therefore this is 11 by 17. Got it clearly? This is a way for the comparison of such type of fractions. So don't misinterpret the situation. Whenever you will get the comparison type of question, never consider you will get the questions always in this format. But this is a basic trick. Suppose if you are able to make the denominators of a set of fractions easily, you can apply this method. Now we can consider the second such comparison. Here, 5 by 16, 5 by 9 and 5 by 12. Here what is the common thing in these all fractions? all the numerators are equal. So, if all the numerators are equal, then the least fraction contains the largest denominator. Don't forget, least fraction contains the largest denominator. Therefore, here we can conclude which is the largest denominator here? 16. So therefore, obviously, that is the least fraction. So 5 by 16. So which is the second largest denominator in this set of denominators? That is 12. Therefore, this is 5 by 12. And the largest fraction from this set contains the least denominator. Here, in this set of fractions, the least denominator is 9. Therefore, the largest common term is 5 by 9. Just remain those 2 points. If the denominators are equal, then the least fraction contains the least numerator. If the numerators are equal, then the least fraction contains the largest denominator. So you can easily compare the fractions with the help of these 2 points. But whenever you look at the questions like this is 7 by 9, 23 by 25, 19 by 21. So is there the numerators equal? No. If the denominators are equal? No. Correct? So then the second point, whether it's an easy conversion to make the numerators are equal or the denominators are equal. Is it possible? No. Again, it's a time-consuming, numerically challenging type of conversion. So either you have to make the numerators equal to their LCM or HCF. In the similar way, denominator also have the same kind of transformation you have to make. But it will take time. Then the next very interesting and the important trick, just observe, is there any interesting common condition for all these fractions? Is it? Yeah, have you got it? Just observe it in a keen way. Is there any common condition for these all fractions? Yeah, now you got. Here, the difference between the numerator and denominators is equal to 2 in each case. And one more important point, all these fractions are proper fractions. Got it? All these fractions are proper fractions. There are 2 points you have to keep in your mind while you are comparing such a kind of fraction. All are proper fractions, plus there is a common difference between the numerator and the denominator in each fraction. So those 2 points are satisfied. Then what is the conclusion here? If the set of fractions are satisfying these 2 conditions, then the comparison, it's an easy task. The least fraction contains the least values. Least values in the sense both numerator and denominator. So if both numerator and denominator are satisfying the same condition, you have to focus only on the numerator or denominator. Means you don't want to go for both the values. Clear? So then, which has the least numerator here? 7 by 9. Therefore, definitely that's the least such value. Got it? So keep those 2 points in your mind. Here, the first point, those are proper fractions. And the second point, there is a common difference between the numerator and denominator. Then what is the conclusion here? Least fraction contains least values. And the largest fraction contains largest values. So here we can conclude 7 by 9 is the least fraction. And second, such least numerator is 19. Therefore, such second value as 19 by 21. And the third such value is 23 by 25. Got it? So what we can conclude as a result of this set? So least fraction contains least values. It's an important understanding. So in the set of proper fractions, if there is a common difference between the numerator and denominator, then the least fraction contains least values. Similarly, the largest fraction contains the largest values. Now we can move to the next example. Here, the comparison between these values, 11 by 7, 35 by 31, 23 by 19. Now you are able to catch the interesting peculiarity of or the common condition for these fractions easily because you are in a track. So here, what is the interesting peculiarity here? Here, all these fractions are improper fractions. That's the next point. Those all are improper. Improper. That means the numerators are greater than or equal to the denominator. And there is again a common difference. So the same point, there is again a common difference. If the proper fractions are satisfying this condition, least fraction contain least values. But here, the least fraction contains largest values. That's the important difference here. So you can keep it in your mind. If it is the case of proper fractions, which are satisfying the common difference between the numerator and denominator, the variation in a proper dimension or the proper way. So the least fraction contains the least values and the largest fraction contains the largest values. If it is the case of improper fractions and there is a common difference between the numerator and the denominator, then the variation in an inverse trend means the least fraction contains the largest values. Similarly, the largest fraction contains the least values. So, which has the largest numerator or largest denominator here? So here, 35 by 31. It has the largest numerator as well as the largest denominator. Therefore, this fraction is the least one. So here we can conclude 35 by 31 is the least one, which is the second such largest numerator, 23. Therefore, 23 by 19. And the largest fraction, it contains the least numerator, that is 11 by 7. 11 by 7. So these are the 4 ways of comparison of fractions. Definitely you will get any one among these 4 types of comparison type of question in your exam. Keep these all 4 types of comparison tricks in your mind. Thanks for watching.